Dear students, how are you? I am Vivek Sharma, your mathematics teacher. I teach class 10th in your school. Here in this video lecture, we will discuss about the method of cross multiplication for solving a pair of linear equations in two variables. In last video lectures, we had discussed the method of elimination for solving a given pair of linear equations in two variables. In this video lecture, we will discuss another algebraic method, which is method of cross multiplication, which we will use for solving a given pair of linear equations in two variables. Before going into deep, for better understanding, please like, share and subscribe my YouTube channel. Let us come on another algebraic method, which is the method of cross multiplication or cross multiplication method. Here, this method is also applied for solving a given pair of linear equations in two variables. So here following steps given below to understand cross multiplication method. First of all, we write the given equation in the form a1x plus b1y plus c1 equals to 0 and a2x plus b2y plus c2 equals to 0, which is the standard form of linear equations in two variables. Okay, any equation is given, you have to write that equation in that form. a1x plus b1y plus c1 equals to 0 and a2x plus b2y plus c2 equals to 0, because we are talking about the pair of linear equations in two variables. So first of all, arrange any equations is given in these standard forms. Here for example is that 2x plus 3y equals to 7, we write as 2x plus 3y minus 7 equals to 0, and 5x plus 3y equals to 5, so we write as 5x plus 3y minus 5 equals to 0. Here these equations are arranged in their standard forms. Okay, now after it you should follow the step 2. In step 2, arrange the given coefficient in this form. Okay, it's a pattern. Now let us come on step number 3. In step number 3, you just write in equation form. Here x upon, which is in array form, that x upon b1 b2, on another side there is the coefficient c1 c2 equals to y upon c1 c2. Here a1 a2 equals to 1 upon a1 a2 and b1 b2, and put the arrows between them. It's the downward arrows and it's the upward arrow. It's the downward arrow, it's the upward arrow, it's the downward arrow, and it's the upward arrow. What is the mean of it? It means that we are doing cross multiplication. Here b1 is multiplying with c2, b2 is multiplying with c1, c1 is multiplying with a2, and c2 is multiplying with a1, and a1 is multiplying with b2, and a2 is multiplying with b1. Now on cross multiplication with each other, put the minus sign between them. Means that when you multiply b1 with c2, so we write as b1 c2 minus b2 c1. Here it is given b1 c2 minus b2 c1. Now let's come on another equation. Y upon c1 c2 a1 a2 is given, so you multiply c1 with a2, c1 with a2, then put the minus sign between them and write down c2 multiply a1, c2 multiply a1. Okay, now let's come on another equation. 1 upon a1 a2 b1 b2, so you multiply a1 with b2, a1 with b2, put the minus sign between them, minus, and write down a2 multiply b1. So it is the expanded form. Again I am repeating it as that x upon b1 multiply with c2 minus b2 multiply with c1 equals to y upon c1 multiply with a2 minus c2 multiply with a1 equals to 1 upon a1 multiply with b2 minus a2 multiply with b1. So here we follow step 3. Solve the above equations for x and y. Here we separate the previous equations in this form. X upon b1 c2 minus b2 c1 equals to 1 upon a1 b2 minus a2 b1, and y upon c1 a2 minus c2 a1 equals to 1 upon a1 b2 minus a2 b1. When you separate it, so you can individually get the value of x and get the value of y. Here when you solve for x and y, So there is condition is that when a1 b2 minus a2 b1 should not equal to 0, because if this is equal to 0, so our value of x and y will be not defined. So therefore this method is called as cross multiplication method. So after evaluating all this, we can say this method is called as cross multiplication method. Let us come on question number first of exercise 3.5. Which of the following pairs of linear equations has unique solution, no solution, or infinitely many solutions? In case there is a unique solution, find it by using cross multiplication method. In this question, they have given a pair of linear equations. So first of all, we have to check that which pair of linear equations has a no solution or infinitely many solution or a unique solution. If any pair of linear equations has a unique solution, so after finding it, we will apply the method of cross multiplication for solving given pair of linear equations in two variables. So let us come on first part of question number first. It is given that x minus 3y minus 3 equals to 0, 3x minus 9y minus 2 equals to 0. So we consider x minus 3y minus 3 equals to 0 as equation number first, and 3x minus 9y minus 2 equals to 0 as equation number second. Now here, first of all, we will find the ratios of coefficients of both equations. So here the ratios of a1 by a2 is equal to 1 upon 3. The ratios of b1 by b2 is equal to minus 3 upon minus 9. On solving we get 1 by 3, and the ratios of c1 by c2 is equal to minus 3 upon minus 2, and on solving we get 3 by 2. So here on checking that the ratio of a1 by a2 is equal to the ratio of b1 by b2, both ratios are equal to each other, but the ratio of a1 by a2 is equal to b1 by b2, but both are not equal to ratio of c1 by c2. Okay, so when this condition exists, so the given pair of linear equations has a no solution, and when there is a no solution, so solution is inconsistent. So in that case, we cannot apply the method of cross multiplication. When there is a no solution in these conditions, so we cannot apply the method of cross multiplication. So here let us come on second part of question number first. Our original equations is 2x plus y equals to 5 and 3x plus 2y equals to 8. Okay, so we write these equations in their standard forms as 2x plus y minus 5 equals to 0. Here we write 2x plus y equals to 5 as 2x plus y minus 5 equals to 0, which is the standard form of linear equations in two variables, and we consider it as equation number first. And we write also 3x plus 2y equals to 8 as our 3x plus 2y minus 8 equals to 0. Okay, and we consider it as equation number second. Now after writing the given equation 2x plus y equals to 5 and 3x plus 2y equals to 8 in the standard forms, here we need to compare the coefficients of two equations. So why we do compare it? Because by comparing we can find that the given pair of linear equations has a unique solution, has an infinite many solution, or has a no solution. So here first of all we find the ratio of a1 by a2, which is equal to 2 by 3. The ratio of b1 by b2 is equal to 1 by 2. The ratio of a1 by a2 is equal to 2 upon 3, and the ratio of b1 by b2 is equal to 1 upon 2. Now here after finding it, we compare these ratios with each other. So on comparing, the ratio of a1 by a2 is not equal to b1 by b2. When this condition exists, so we say that the pair of linear equations has a unique solution. The pair of linear equations has a unique solution when the ratio of a1 by a2 is not equal to b1 upon b2. Now after, you know that in the question it is given that when the given pair of linear equations has a unique solution, so please apply the cross multiplication method for solving given pair of linear equations. So here we apply cross multiplication method. First of all, we arrange the given coefficients of the both equations in that form. Here the x upon b1 b2 c1 c2 equals to y upon c1 c2 a1 a2 equals to 1 upon a1 a2 b1 b2. So the value of a1 is equal to 2, b1 is equal to 1, c1 equals to minus 5, a2 equals to 3, and b2 equals to 2, and C2 is equal to minus 8. So here the value of B1 is equal to 1. Here the value of B2 is equal to 2. Here the value of C1 equal to minus 5 and the value of C2 equal to minus 8. Here the value of C1 equals to minus 5 and the value of C2 is equal to minus 8 and the value of A1 equals to 2 and the value of A2 equals to 3. The value of A1 equals to 2 and A2 is equal to 3 and B1 is equal to 1 and B2 is equal to 2. Now here put the arrows between them. This is the upward arrow and this is the downward arrow, which means that you are cross multiplying the 1 with minus 8 and 2 with minus 5. Here when you multiply 1 with minus 8, so you will get minus 8, and you multiply with 2 multiply with minus 5, you get minus 10. So during multiplying put the minus sign between them. So here in the expanded form you write as 1 multiply minus 8, so you get minus 8. फिर put the minus sign between them. Multiply 2 multiply minus 5, so bracket minus 10. So we solve this, we get minus 8 minus bracket minus 10. Now let us come on this equation. Here minus 5 is multiplied with 3 and minus 8 is multiplied with 2. So on multiplying minus 5 with 3 we get minus 15. Put the minus sign between them. Here after minus sign we multiply minus 8 with 2, so we get minus 16. Now again let us come on equation 1 upon this. So here 2 multiply with 2, so we get 4. Put the minus sign between them and we multiply 3 with 1, so we get 3. Now on solving we get x upon minus 8 plus minus minus plus, so minus 8 plus 10 equals to y upon minus 15. Here minus minus positive, so plus 16 equals to 1 upon 1. Here on solving the previous equations we get x upon 2 equals to y upon 1 equals to 1 upon 1. Now after solving here we get this. Now we can see that x upon 2 is equal to y upon 1 and y upon 1 is equal to x upon 1, and they are equal to each other. It means x upon 2 is also equal to 1 by 1 and y upon 1 is also equal to 1 upon 1. So here for finding the value of x and y, here we separate them as individual equations. So here we take x by 2 is equal to 1 upon 1 and y upon 1 equals to 1 by 1. So x upon 2 equals to 1 by 1 and y upon 1 equals to 1 upon 1. So on cross multiplication we get the values of x equals to 2 and we get the value of y equals to 1. Hence the solution of given linear equations is x equals to 2 and y equals to 1. Okay, so I hope you have understood the method of cross multiplication, how we applied that method for solving a given pair of linear equations in two variables. Please do some extra questions at your home for better understanding of this method, and please do revision of the previous exercises. Okay, I will upload a PDF of some extra questions for related to that method.